Okay, we are going to work on problem number 34 in chapter 15, solutions. And the thing with solutions, you're going to have to use the tables in the text, or you're going to have to look them up online for the numbers. So I think part of the problem with this problem number 34, page 475, is that you need to collect the data first. So it says, what are the boiling point and freezing point of a 0.40 molar solution of sucrose in ethanol? So if I look at that formula, I need to know freezing point and boiling point. And the way to find freezing point and boiling point of a solution is to use the K value, which you have to look up. K value you have to look up. And that's for freezing and boiling of whatever your solution is. And this solution happens to be a solute of sucrose in ethanol. Ethanol is the key one we have to look up on the tables, so maybe you didn't know that part. And then they gave us the M value, which is going to fall here and here for ethanol, and that is 0.40 M. Okay. So for doing the formulas and finding these, they're pretty quick and simple. It's just a matter of where do I get my information from. So if you use your text, you're actually going to get your information from table 15-5, ethanol. We have our freezing point, which we're going to have to subtract when we find our change in it, change in freezing point. We're going to have to use this one because this is the freezing point of ethanol. And we're going to need to use the K value, which is a constant of 1.99. And then for your boiling point, it's going to be on this page, page 472, and you're going to use ethanol boiling point, and your K value is going to be 1.22. Your practice problems that they were using in here, they were considering water, and so they were using the value for water because it says aqueous solution, so that's a water, that's solution in water. And I think that gets confusing when in the problem that you're looking at, they're asking for ethanol. So let's set that up. You know where I'm finding my information is on the tables. And sometimes they'll have that information in the appendix in the very back of the book. There's an appendix. And they have tables back there that have K values in them. So we'll flip back there real quick and I'll show you how to find that. So here we have K values too. We have specific heat values for our energy things. We have delta H values, freezing points, K boiling point, K freezing points. So we've got some values here. So just be sure that you check all your tables first before you say, oh, I can't do it, I can't do it. I know it's kind of tough to kind of extrapolate the information. So now that you know it's sucrose, this is like taking sugar and sticking it in ethanol, which is like an alcohol, and creating a solution. Plugging the numbers in is pretty straightforward if you use your tables. So from the table, 15-5, my KF value is 1.99 degrees Celsius in the molar solution. And then my actual freezing, what was it? K value for that. T value for freezing was negative 114.1, which makes sense because it takes a lot to get it to freeze. It has to be really, really, really cold. Just a standard freezer won't freeze it. And then I go to table 15-4, and I get my KB value for boiling point, and that's 1.22 degrees Celsius in a molar solution. And then my temperature for the boiling point, to boil it, it doesn't take much. It is 28.5. Double check that real quick. Oh, sorry, 78.5. 78.5. I thought that was a little low. All right. So around 78.5, it starts boiling. So these numbers are all going to be placed. So here's these numbers get placed in here. These numbers get placed in here, but remember this is change. So we have our initial minus our final. So this is your initial for the boiling point, and then you minus the final. So you're going to end up taking negative 114.1 minus the T value, the temperature that we're looking for. So that's that side. For this side, we're going to take 78.5 and subtract it from the T value that we're going to be getting. And then that will equal our KF. KF, 1.99. And the M value they gave you. And this does not break down into electrolytes, into little bits and pieces, like the sodium chloride would. Sodium chloride would actually form electrolytes. So I have 1 mole here and a 1 mole here of the electrolytes, but this one does not do that, so it's just the same number, 0.40, and same here, except for I got to use that one, 1.22, and we still use 0.4. Okay, and then it's up to you to do the math. So to make this simple, we could say that the change of this is going to equal that. So you can actually do this mathematically and then just take that number and subtract it from this one.